Hello, in this video I'm going to talk about the structure of soap. Okay, the soap that we are studying. So we can draw the structure of soap like this. Okay, so we can easily draw the structure of soap like this. So this is structure given in our NCRT textbook. Okay, so first let us write the definition of soap. Okay, and understand it. So soaps are sodium or potassium salts of long chain carboxylic acids. So you need to understand, we can redraw this structure in this way also. Okay, so this will be also correct. So here there is a double bond, here there is a O minus, and it's connected to Na plus. So this one is a simplified structure. Okay, this one is given in NCRT textbook. This one is also correct. So instead of this Na plus, here K plus can also come. So you need to understand what is a salt. Okay, salt means salt is an ionic compound of an anion and cation. Okay, so it's an ionic compound between an anion and cation. Anion means negatively charged, cation means positively charged. So this is the cation. Okay, and the remaining, this long chain is the anion. So if you wonder what is these lines, okay, these lines, what are these lines? These are actually hydrocarbon chains. Okay, so a structure like this, see, I can draw one structure like this. Okay, this is a hydrocarbon, so like this. So this is propane. Okay, the simplest way of representing this structure is drawing lines like this. So what we are assuming is that the ends are ends in the ends, and where the lines meet we will assume that there is carbon, and we will assume that there is enough hydrogen bonded with it. Okay, so that is how we draw this type of structures. This is the simplest way of drawing the structure. We can also draw, okay, this is the structure of butane. Okay, if any double bond is there, we will draw a double bond like this. If there is a substituent, we will draw it like this. Okay, this is a way of representing organic compounds. Okay, so that is what this long chain means. So long chain is actually hydrocarbons. So the next thing is, so we already studied soaps are sodium or potassium salts of long chain carboxylic acid. So the one general formula we can write is, so since this hydrocarbon chain, we can take it as R. Okay, and here there's a carbon, so C2O is present, Na. Okay, this we can say as the general formula for soap. General formula. Okay, RCOONA. So I can write it neatly, RCOONA. Okay, this is the general formula for soaps. And you also need to understand one more thing. Like in the image, soap is having two ends. Okay, so this end is the ionic end. Okay, this end will attract water. So that is why it is also called, hydrophilic end. Okay, hydro means water. Okay, hydro means water. Philic means loving. Okay, philic means loving. So that end is loving water. That means that end attracts water. Okay, that is the meaning. So this end will attract water. And you know this end, what it is called? This end is called hydrophobic end. So this end will repel water. Okay, repel water. But it will attract hydrocarbons, attract oils, etc. Okay, because they are hydrocarbons. So it will attract hydrocarbons, but this end will repel water. So these are the things you need to know about soap. Okay, so this is the structure of soap.